Hello everyone, my name is Julian Edwards. I'm a DBA student at the California Intercontinental University, and today I will be discussing conducting a simple regression. Our agenda for today's presentation will include discussing what is regression, the confirmation rule. We perform simple regression tests using the GRC 605 dataset. We'll then continue on with our main takeaways before finishing up with our annotated bibliography. Now, regression can be defined as a statistical test used to determine whether there is a significant linear relationship between an independent variable, usually marked x, and a dependent variable y. This test focuses on the slope of the regression line, and if the slope of this regression line is significantly different from zero, a significant relationship exists. Our confirmation rule can aid in determining if a test is statistically significant by using the 95% confidence interval. If the confidence interval includes zero, the test is not statistically significant. If the confidence interval, however, does not include zero, then the test is statistically significant. For a first regression test, we ask the question, can we predict an individual's debt by knowing their income? So we performed the following regression test where our null hypothesis stated that the regression coefficient of beta was zero. The alternative hypothesis stating that the regression coefficient is non-zero. A simple linear regression was conducted to observe whether an individual's debt can be predicted by knowing their income. From this test, no significant regression was found, where our regression coefficient was found to be minus 0.05, our r-squared was 0.00 with a p-value of 0.535. Of course, our alpha value would have been set at 0.05. And from our printout from our PSPP data software, you can see that using our 95% confidence interval, a range from minus 0.01 to 0.01, which includes zero, and as such, there is no statistical significance from this regression. Our second regression test, we ask the question, can we predict an individual's savings by knowing their income? The following regression test was conducted where a null hypothesis was stated that the regression coefficient is zero, the alternative hypothesis being that the regression coefficient is non-zero. Again, a simple linear regression was conducted to observe whether an individual's savings can be predicted by knowing their income, and a significant regression was found, where our regression coefficient was found to be 0.91, our r-squared value 0.82, and a p-value 0.000, which is strongly significant. From our printout, additionally, we see that with our confidence interval, it ranges from 0.09 to 0.11. This does not include zero and adds to their significance. For a third regression test, we ask the question, can we predict an individual's portfolio value by knowing their savings? The following regression test was conducted where a null hypothesis was stated that the regression coefficient is zero, with an alternative hypothesis stating that the regression coefficient is non-zero. A simple linear regression was conducted to observe whether an individual's savings can be predicted by knowing their income, and a significant regression was found, where regression coefficient was found to be 0.28 with an r-squared value of 0.07 and a p-value of 0.000. Again, from our output, you can see using our 95% confidence interval that it ranged from 0.07 to 0.25, and this did not include zero, which means that there was a significant regression. Our takeaways from this presentation are that a regression determines whether a significant linear relationship exists between two variables, the independent and dependent variables. The r-squared value highlights how close the data presented are to the fitted regression line, and your confirmation rule can be used to determine if there is a significant regression by using the confidence interval. Throughout this course, there were 3 articles that would have stood out and would have been vital in completing this course. First article would have been titled The Chi-Square Test of Independence, This article explains the chi-square test as a test for hypotheses when variables are nominal and provides detailed information on exactly which categories may account for any differences found. Assumptions of the chi-square test are highlighted, and it also explains the need to pair this test with an appropriate test of strength. Interpreting the results of the chi-square test when run is also discussed thoroughly in this article. A next very relevant article was the article on correlation presented in Research Methods Knowledge Based. And this article defines and describes the statistical test correlation and how it can be applied to everyday problems. It provides the mathematical derivation for the statistical figure and explains in detail what the results from a correlation test may indicate. In addition, it also explains testing the significance of any correlation using statistical software. Finally, hypothesis test for regression slope article explains the regression test and its use in statistical analysis to determine the presence of a relationship between variables of interest to researchers. The article explains the mathematical derivation of regression and its use in hypothesis testing to draw conclusions from the statistical data available. The articles go through all steps of conducting a simple regression, including stating the hypothesis and analysis planning, sample data analysis, and finally interpreting the data output. These three articles provide a great deal of information regarding the main statistical tests that are frequently used in business research and quantitative statistics. With the knowledge from these articles, the doctoral candidate is now able to run statistical tests independently when necessary. Additionally, the candidate will be better able to discuss research and statistical issues with expert researchers to solve problems in the workplace. Thank you so much. If you have any questions or comments, please feel free to ask.